In this video, we're going to look at the next few examples on simplifying surds. Previous videos we looked at how to simplify surds, but now we're going to look at problems involving addition and subtraction as well. We've got 3 examples to work through. Okay, example 6, simplify the following. Root 63, subtract root 7 plus root 28. So when we're looking at these, there are often clues in the question. There are often surds that cannot be simplified that will give you that clue. For example, 7 is a prime number, so that surd cannot be simplified. So that's making me think that, well, maybe some of my other surds will involve a root 7 somewhere. It's like a wee guide for us. So we're going to simplify each of these individually. So I think, what's the biggest square number that goes into 63? Well, that's 9. That's 9 times 7. There's that 7. Take away root 7 plus, what's the biggest square number that goes into 28? Oh, it's 4. And that's 4 times 7. I've got that 7 keeping popping up. I can split up my surds. Root 9, root 7. Subtract root 7 plus root 4, root 7. Square root of 9 is 3. 3 lots of root 7 minus root 7 plus 2 root 7. And now this is just a case of collecting like terms here. Remember, there is an invisible 1 in front of this here. Okay, although it's not written, we know that there's a 1 there. So I've got 3 lots of root 7 minus 1 lot of root 7. Well, that's 2 lots of root 7 plus 2 lots of root 7, which is 4 root 7. And that's our final answer. Sometimes the clues are not there, but often they are. And when they are, make sure you use them. If they're not, just simplify as normal, and then you'll find that usually it'll involve the same, like surd. Okay, that was example 6. Let's have a look at example 7. Let's have a look. Is there any clues here? Well, this 2 is prime, so I can't simplify that. So maybe my other surds will simplify to be something involving a 2. Let's have a look. So we've got 8 root 2 plus 5 lots of, what's the biggest square number that goes into 8? Well, it's 4. And that's 4 times 2. There's that 2 again. And then I'm subtracting root 98. Well, what goes into 98? What square number goes into 98? That's 49. 49 is 7 squared, and 49 times 2, there's that 2 again, is 98. So we can then start to split up our surds here. So then we've got 5 root 4 root 2 minus root 49 root 2. 8 lots of root 2 plus. So this value here is 2. And what I've got is I've got 5 lots of that. So 5 lots of 2 is 10. I've got 10 lots of root 2. Subtract 7 lots of root 2. We've now got all like terms. They're all root 2's. So 8 plus 10 is 18 minus 7. That's 11 lots of root 2. Last example. I'm going to change this actually. I'm going to take out this value in the middle here. We're going to do root 125 subtract root 75. So in this problem, there is no obvious surd that goes into both of them. Okay, there's not a clue here. So we're just going to have to resolve both of these and see where we get. So think about, what's the biggest square number that goes into 125? There's actually a clue. It's actually 25. Because in the 25 times table, it was 25, 50, 75, 100, 125. So it's going to be 25 multiplied by 5. And root 75 is going to be root 25 multiplied by 3. We can split these up. That's going to become root 25 root 5 subtract root 25 root 3. We're going to get 5 root 5 subtract 5 root 3. The answer to this is not 5 root 2, for example. because these are different quantities. Root 5s and root 2s cannot be added together. Just like when we collect like terms, 2x plus y plus x plus 4y, you would do the x's together and you would do the y's together. So here we've got root 5s and root 3s. We can't combine them. So in this problem, this is as simple as our answer can go. So this is our final answer. Hope that was helpful. Those examples 6, 7, 8 on simplifying surds. Thank you very much.